Welcome back to the Interstellar Exploration Devlog series. Last video I showed off my work in progress ship tileset, and since then I've decided to implement it, discovered that the scaling was off, scrapped it and restarted. Now I have this tileset. It looks pretty much the same. I imported the second attempt into Unity and started creating prefabs to snap together. Once I had created a test ship, I went to test it in game, and that's when I realized that the lighting in space is kind of buggy. It turns out that in the universal render pipeline, which I am using in my game, point lights can't cast shadows, and at the moment the sun is just a gigantic point light. So I've got a bit of a problem here. The solution I've come up with is to turn the sun into a directional light that is always pointing towards the local player's ship. However, this does break lighting for planets though, so we're going to have to fake the planets being lit. The way we're going to do this is by changing the planet and planet atmosphere shader to be unlit and only shade the faces that are facing the sun's position. In this case, it's 0, 0, 0, but that may not always be the case in the future. The way we calculate which faces to shade is we take the object's position in world space and subtract it from the sun's position, then divide that difference by its own magnitude. Then we get the dot product of that value and the face's normal vector and multiply that clamped value by the stored vertex color in the mesh. The ship is still pretty dark, and the planets, while correctly lit, are still ugly, but it's good enough for now. I was starting to implement some gameplay mechanics when I realized that testing is going to be a real pain in the ass without some sort of command console. At this current point in time, I have a really scuffed chat commands implementation. It's really hard to add new commands, and it's just kind of finicky. So what I'm going to do is steal this solution from Game Dev Guide and implement it into my chat system. The first command I added was the beam down command, and as you can imagine, all it does is it takes a player from the comfort of their spaceship to the planet below. This solution that I stole from Game Dev Guide makes it really easy to add new commands as well. It's all kind of just stored in a list, and I'm really glad I came across it. After I did this, I decided to have a play around with Unity's animation rigging package and tried my hand at inverse kinematics. It didn't go that well, so I ended up just making a state machine and doing animations the old-fashioned way for the time being. Anyway, now to do something that's actually on the Trello board: planet settings and terrain tools. So essentially I want the terrain's height data for each planet to be accessible outside of the actual scene. I thought a good way to go about doing this would be to write the height data to a texture and have that texture stored in the planet settings object for each planet. To do this, I'm going to need to modify my terrain generator to store the settings I use when generating a terrain. I started by creating a scriptable object to store the terrain settings in, and updated the terrain generator to use the parameters in this new terrain settings object. The next thing I did was add a button that takes the height data from the Unity terrain data object, writes it to a texture, and sets that texture as the height map property in the planet settings object. Now that that height data is in a texture, I can have a crack at shoreline detection. This has bothered me for quite a while now. At the moment, waves don't get smaller as they approach the shore. This means I can't have large stormy waves out at sea without low-lying inland places getting flooded every time a wave passes. My idea to fix this was to get the ocean system to sample that height map that we've now got conveniently stored in our planet settings object, and then use that to adjust the wave height accordingly. So I started off with the water shader and created this subgraph which translates the ocean tile coordinates into values between 0 and 1, and then uses those values to sample the height map. After this, all I needed to do was subtract the sampled value from 1, and then multiply that by the wave height. Now this is a pretty good start, but I would like to have more control over the wave height, so to do this we're going to add a value between 0 and 1 to the sampled value before we subtract it from 1. Now when I adjust this value on the material, I should have more control over how flat the waves are. This is pretty basic and there are more things I could do to get better waves, but for now this is good enough. I just have to update the physics system now with the same changes I made to the shaders, and we should be done.